So hello and welcome back to A Tale of Genetic Code, and in this video we'll finally start identifying chromosomes on metaphase spreads. So like I explained in my previous video, this is my setup. I use Obsidian for visualizing and annotating these metaphase spreads, which I've taken from the website, which I'll be adding in the description below. And these are just the labels for different chromosomes, and I can just pick them up and label these chromosomes. And obviously this is just a picture of the metaphase spread which I have taken from the source I mentioned below, and I've just pasted it over here. So the first thing I will do is lock this in place, because obviously I don't want it to be moving as I'm annotating these chromosomes. And along with this, what we'll also have as a tool for reference is a hand-drawn ideogram of a karyotype, ideogram of various chromosomes, uh, so that in case of doubt we can refer to them, and hopefully we'll be able to solve this metaphase spread. So before we start anything, we first need to actually count the number of chromosomes, because aneuploidies are the easiest to detect, because you just have to count the number of chromosomes and then you will know that you either have an extra or a missing chromosome. So we'll start off with that, and for doing that, the easiest way I've realized is to mark down boundaries for various sectors within this metaphase spread. That makes counting much easier. So there's no uh, rule to this, but in general try to uh, have these sectors with roughly equal number of chromosomes in each, so that counting is easier. But otherwise, apart from that, there is no other role for this uh, particular activity. So here I will probably make one sector over here, and maybe I can leave this entire, or I can make one more here. So like I said, there's no rule to this. You can do it as per your liking, and remember that this is again an object that we have created in Excalibur. So we need to lock these also in place, otherwise they also will keep moving as we are labeling these chromosomes. So where is lock here? Unlock. Oh, I selected the picture of the metaphase spread by mistake, so I'll just lock all, and I'll lock this as well. So now you can see that none of these things moves, and now I can first count the number of chromosomes and then start identifying them, right? So 1 2 3 4 5 6. I'll just pull a 6 from here and put it here. I'll label it with red to differentiate from chromosome labels. And if I count here 3 4 5 6 7 and 8, so I'll just pull an 8 from here, increase it in size and label it with red. Again, here we have 4 5 6 7 8 9 and 10. Let's pull a 10 from here, increase it in size and label it with red. Coming at the center here, 4 5 6 7 8 and 9. So we have 9 chromosomes at the center. I'll just put it like this and change its color to red. We have 4 4 8 chromosomes here. Increase its size, label it with red. So these are 3 4 5 6 7 and 8. Yeah, 2 3 4 5. So there are only 5 chromosomes over here. We can label them like these, like this, like these. Okay. So now what we have to do is count the number of chromosomes. So 8 8 16, that would be 26, 32, 37 and 9 would be 46, right? 37, 38, 39, 40, and 6. Yeah. So this is at least a euploid metaphase spread, and so we'll just start off by identifying chromosomes. So one trick to identify chromosomes easily and to not get confused while doing this is to start off by identifying the different groups of chromosomes. And the easiest among all are the acrocentric chromosomes of groups D and G. So that is what we'll be identifying first. And to do that, one simple way of doing it is actually circling these chromosomes. So for example, this is an acrocentric chromosome. This is actually chromosome 21. This is another acrocentric chromosome I could find here. This is actually chromosome 22, but we'll get to it. And there's another acrocentric chromosome over here. So that is 4. This is another one. So you can see this is an acrocentric chromosome. Don't get confused with this little stubby thing beyond the centromere here. That is actually just the satellite, and it is a feature of these acrocentric chromosomes. Sometimes it can be confused as a small arm, short arm of the chromosome, and you would think it is a submetacentric, very submetacentric kind of a chromosome, but that is not the case. This is just the satellite, and this is actually a acrocentric chromosome. So what we have identified here are the smallest chromosomes in a karyotype, and these belong to group G, and they include 21 and 22. But even group D has acrocentric chromosomes, but these are larger. So for example, this is an acrocentric chromosome. So we'll label this as well. Where else can you find these? So over here you can see one. So I've labeled this as well. There are quite a few in this portion of the metaphase spread actually. There's one over here as well. So marking these out helps in differentiating the chromosomes you have already identified from the chromosomes that are remaining to be identified as well, because later on when you've identified a number of chromosomes, it gets really confusing as to what is left and what is already done. So this is a good exercise to do. Where else can we find acrocentric chromosomes? Yeah, there's one over here. So I can just take this one and put it over here, change its rotation a little bit. So did we identify 10 of these? 3, 4, 5, 6, 7, 8, and 9, and 10. So there are 10 acrocentric chromosomes in a female karyotype and 11 in male karyotype, because the Y chromosome is also an acrocentric chromosome, but I am not able to identify any more acrocentric chromosomes in this metaphase spread, which probably means that this is a female uh, karyotype, right? Uh, Having identified these acrocentric chromosomes, we can just start numbering them. So the easiest one to identify actually, and the very first one that I learned, was chromosome 21, because it is like a small V with a triangular dark band at the centromere. So if you look at the hand-drawn ideogram, it looks something like this. Obviously it is reversed here, so it looks like an A. So if you're looking for another one, it is right here. And once you identify the 21, 22 is also very easy, because 22 just has a dot for a centromere and no particularly dark bands in the rest of the chromosomes. So this is another 22. So this is already 4 chromosomes identified and group G done. So now we'll come to group D, which has chromosomes 13, 14, and 15. So chromosome 13 has these distal multiple dark bands, and that is a characteristic feature of chromosome 13, and luckily we found both of them side by side. So I'll just take 13 from here and put it over here, take this one and put it over here. Chromosome 14 is similarly sized, but has a distal dark band and a proximal dark band, with the rest of the chromosome being otherwise bandless. So this is one chromosome 14. Where might we find another chromosome 14? Yeah, so here you can see that there's a proximal dark band and a distal dark band. So these two are chromosomes 14, and we can just label them like this. And then chromosome 15 actually has only proximal dark band, with the distal part being relatively light. So you can see one over here and one over here. These are both 15. And just like that, we have identified 10 whole chromosomes out of 46. Great work. So after identifying the D and G groups, what I like to do is actually identify the first three chromosomes that belong to the A group. So A group being at the very top of the karyotype are the longest chromosomes, and thus they are easiest to identify. And chromosome 1 has this characteristic feature of having a dark uh, band right below the centromere. So this is the P arm and this is the Q arm. And the P arm actually has a very light, smudgy kind of a band at the very tip. So that is the identification feature of chromosome 1. And we can find chromosome 1, another one, right here in the same sector of this metaphase spread. So that is great. We have already identified chromosome 1. Now chromosome 2 does not have very prominent band at the center, that is at the centromere, but the rest of the chromosome is very well banded. So you are looking for a chromosome that is similarly sized to chromosome 1, but has multiple bands and no particularly dark staining at the centromere. So this looks like chromosome 2. And if I am to find another chromosome 2, uh, so where is the other chromosome 2? Okay, we'll get back to it. Let's try to find chromosome 3. So chromosome 3, if you remember, has very dark staining on either side of the centromere and relatively few bands on both its arms. So we are looking for a very long chromosome. Where are all the long chromosomes? Hmm, yeah, so here. So you can see that at the centromere we have quite a dark band on either side, and then relatively light arms with distal dark bands on both the arms. This is undoubtedly chromosome 3. And if I am to find a similar looking chromosome, I would say it is this. Again, you can see that the centromere has these uh, dark regions, and then a relatively light uh, section on both the arms, and then a distal dark band. So this is chromosome 3. That begs the question, where is the other chromosome 2? Are you able to find it? Oh, so I think this one is actually folded a little, and that is why it appears very dysmorphic. But if you see closely, the banding pattern actually is quite uniform across both the arms, and the centromere appears to be not very densely staining. This is chromosome 2. So we have identified actually 16 chromosomes of the 46, just 13 more to go. We have identified groups A, D, and G, and at this point we can do either, okay, let's do group B, which includes chromosomes 4 and 5 first. So this group has very submetacentric chromosomes, which are again quite large. So let me just mark them with say blue. So this is a large submetacentric chromosome, and if I am to find similar chromosomes, uh, this is another one right next to this. can you find others? Okay, there's one over here. So I find actually identifying chromosomes to be a very uh, soothing and a very peaceful exercise, because it is just like a game. We are finding pairs and identifying them based on some criteria. So it is quite fun for me, and I'm excited that I have so many unsolved chromosomes that I can uh, do when I'm bored or free. So here you can see that this is a submetacentric chromosome, uh, and these are the four basically. We just have chromosomes 4 and 5 in this group, so not many to look for. I'm just eyeballing the rest of the chromosomes to see if I by mistake labeled one wrong. Uh, why does not look so? So this chromosome here is chromosome 4, and I say that because there is a dark shoulder band right distal to the centromere on the long arm, and there is a similarly staining dark band on the short arm as well. So this is the identification feature of chromosome 4. If you look at chromosome 5, you can see a similarly staining dark band on the short arm, but the longer arm has several bands over here. And if you can imagine this chromosome being shrunken down a little bit and the white between these dark bands disappearing, this would actually appear like a box. So chromosome 5 is said to have a box band on its longer arm. So this is actually chromosome 5. So we have identified 1 4 and 1 5, and here again you can see a dark shoulder band which makes this chromosome 4, and that would make this the remaining one, chromosome 5. So we have like identified already 18 chromosomes, and that was fast, right? It was not at all time taking. So now let's switch tracks. Let's try to go at DEF group. So F group has actually metacentric chromosomes, but they are very very small. So they would be similarly sized to your chromosomes uh, 2021. So like this one. So I'll just circle them with a different color. What have we not used? Green. Okay, so this is a green metacentric chromosome, and let us take it to this one. Again, this appears to be metacentric, and yep. So there are two more to go. There's one over here, one more, just one more to go. Can you find it? Yeah, it's over here. So these chromosomes, which include chromosomes 19 and 20, are very easy to identify. Chromosome 19 just has a dark centromere, with the rest of the chromosome being relatively light. It looks like a bow tie. And so these two are chromosomes 19. So chromosome 20 would be very similarly sized, but it would have some banding structures, some bands on either arm. So this is chromosome 20. That's great. We are going at a great speed. Uh, that leaves actually just the group C, right? And the sex chromosomes. Group C, D, okay, group E is also left. So we can start off with group E because they are relatively easier as compared to group C, which might be slightly confusing, but we'll see how to navigate that. So this is one chromosome of group E, and you can say that because these are very submetacentric chromosomes, and they are very small in size, unlike the other submetacentric chromosomes of group B, which are very very large. So you can just see the difference in the size, right? uh, so this is one, and we can see another chromosome just like that over here. Can you find the others? Yeah, there's one right here, right next to the previous one. Hmm, three more to be identified. There's one over here. There are two over here actually. So there you go. There you go. And another one right here. So this looks very weird, uh, but actually if you see closely, there's a dark centromeric band and a dark band on the long arm. So these two are actually homologous chromosomes. Crazy, right? I think we have identified all six of this group, and then let's start naming them. So the easiest one to identify is chromosome 16 in this particular metaphase spread. I have seen metaphase spreads with very bad looking 16s, but here they have come out very beautifully. So you can see that there's a dark band in the centromere and then two other dark bands just below it. So below it because this is actually the long arm, and that would make it look like a skirt. So if you see here, this is how it is represented as an ideogram. It looks like a skirt. So 1 2 3, this is chromosome 16. And like I said, chromosome 17 instead of these three bands has only one band on the long arm, and this is chromosome 17, and this is chromosome 18. And just like that, by elimination, you can say that the other two chromosomes that we have identified in this group are chromosomes 18, but what gives them away is their box-like structure on the long arm. So the long arm is actually delineated by these two very dark bands, and it's often quite appears quite short on metaphase spreads, and it gives some kind of an appearance of a box. So that is how I remember chromosome 18. And now we are left with only the sex chromosomes and the group C, and let us start identifying group C then. So we can start with chromosome 6. So remember that chromosome 6 has a very large light band on the P arm, that is a short arm, and luckily we found both of these chromosomes lying side by side, so we can label them right away as chromosome 6. Now coming to chromosome 7. Chromosome 7, remember, has the darkest bands, one of the darkest bands on uh, among all the chromosomes. So, and the number of bands on the Q arm are 2. So you have two very dark staining two bands on the long arm of chromosome 7. So you can just label this as 7. And if you see, this is another 7 right here. So we found both the 7s also quite close by. That is great. Chromosome 8 and 9 are often confusing, so I would leave them at, for the end. Whereas chromosome 10 is quite easy to identify because it has these three dark bands on its long arm. So like 7 has 2, 10 has 3, and right away you can label this as 10. And right away you can label this as 10. You can see another chromosome with three dark bands on the P arm. So we are left with 11, 12, 8, 9 and the sex chromosomes. 11 and 12 are very easy to identify again because 11 has this very large uh, light band right below the centromere, below because again this is a long arm, this is a short arm. So if you see, this is chromosome 6, it has a large light region on the P arm, whereas chromosome 11 has a large light region on the Q arm. And if we find another chromosome that looks like this, we would have a pair. So it's right here, that is chromosome 11. And 12 actually looks very much like 11, but this dark band is more proximal to the centromere, and thus this light staining region is smaller in chromosome 12. So if you see this one, this is chromosome 12. Okay, this is chromosome 12, and if you can find another chromosome 12, it is right here. It's right here. So we found both chromosomes 12 as well. So we are left just with 8 and 9 and X chromosome. Remember, we did not find another unpaired acrocentric chromosome, so probably this metaphase does not have a Y chromosome. So I'm assuming this is a female karyotype, and we'll label the X chromosome at the end. So remember that chromosome 9 has two dark bands on the long arm, and you can see one or two dark bands on the P arm as well. That is the feature of chromosome 9. So let me just label it as 9. And if you can see another chromosome that looks like that. Hmm, can you find another one that looks, yeah, so I think this one looks like that, right? So there are these two dark bands on the short arm, and then there are these two dark bands on the long arm as well. So I would call this as chromosome 9. Now chromosome 8 is also something like chromosome 9, but usually the P arm has just one band. So you can see this, there are two dark bands here and just one dark band on the short arm. So this is chromosome 8. So we should be left with just three chromosomes. One is this, which is very weirdly placed, the other is this, and the other is this. So remember, the easiest way to identify chromosome X are these two dark bands. Again, they are somewhat like shoulder bands, and they are equidistantly placed from the centromere, giving the appearance of a bikini. And actually these are called the bikini bands, and you can see them over here as well. So our hunch was right, this is a female karyotype, and we get one X here and one X here. So we have labeled all the sex chromosomes as well, which leaves us with one chromosome unidentified and one number unassigned. So just by elimination we can label this as chromosome 8, but let us just check whether both these chromosome 8s match. So if you can imagine this to be the centromere, then you can see one dark band over here and a few dark bands over here. Obviously the banding pattern on the long arm is not going to be clear because of the folding, but I would say that it is not inconsistent with the X chromosome or with the chromosome 8. And so in a euploid metaphase spread, we have identified all the chromosomes. So finally we can just label this karyotype as 46XX, which is normal, right? Let us give this a cool new color. This Okay, I'll just label it as 46XX. And before we end it, let us just match it with the key. So remember that the source from where we have taken these metaphase spreads also have a matching key for each of these metaphase spreads. So you can check it by this number over here, ZWK9904, ZWK9904. So both the chromosomes 1 we had identified over here, they are over here. So remember this weird chromosome that we had some difficulty in identifying. This is chromosome 2, as can be seen here. Chromosomes 3, so the other chromosome 2 is here. This is the one placed exactly like that, right? So chromosome 3 is over here and the other one is over here. So again we can just see them over here. And remember the chromosomes 4, I told you that there would be a very dark shoulder band. So you'll have one or two dark bands on the P arm, but this shoulder band is the absolute giveaway for chromosome 4. As far as chromosome 5 is concerned, there are multiple dark bands, a little bit more distal to the centromere, and it would give the appearance of a box on a shorter chromosome 5, and this is actually called the box band. And remember that we had chromosome 6 quite close to each other, and they are given away by this large light region on the P arm. Chromosome 7, like I said, have some of the darkest bands on a metaphase spread, and they are thus easy to identify. Again, two dark bands on the long arm. So like we had identified this chromosome 8 based on elimination, but again See, you can see these dark bands here and probably one dark band here, but obviously unless this chromosome is straight, we would not be able to really comment about it probably. But the beauty is that on a single slide we'll have tons of metaphases. So if you're having a doubt regarding the nature or abnormality of one chromosome in one metaphase spread, you can always go to another metaphase spread and check out the chromosomes over there. So chromosome 9 we had identified over here. So one or two dark bands on the P arm and some dark bands on the Q arm as well. So the other chromosome 9 we had identified it over here. So you can see that both of these chromosomes identified correctly. Again, the three distinct bands on chromosomes 10 and 11 having a large light region just distal to the just proximal to the centromere. Again, chromosome 12 very similar, but the light band is much shorter. And chromosome 13, like I said, there are multiple bands all across the chromosome, but more clustered distally. Chromosome 14 would have some dark bands proximally and one dark band distally. So that is the way you identify chromosome 14. So if we see it on our metaphase spread over here, a distal dark band, a proximal dark band, and a distal dark band and a proximal dark band. Chromosome 15 has these bands only proximally, and chromosome 16 has this nice frock-like appearance. Chromosome 17 has a single dark band on the long arm. Chromosome 18 appears like a box, like you can see here, probably like a gift box or a, yeah, like a gift box maybe. And it's actually very easy to identify. Chromosome 19 has a single dark region at the centromere, and the rest of the chromosome is relatively unstained. Chromosome 20 is similar to chromosome 19 but with more defined bands on either arms. Chromosome 20 and 21 we've already seen. Chromosome 21 has a triangular dark band on its arm, and chromosome 22 actually has only the centromeric staining with ill-defined dark bands on its arm. So we have finished identifying our chromosomes on our first metaphase spread, and I guess this is it. Thank you.